So the covers are off and the seats are out. Now it's time for your IA to go through the majority of the inspection. The entire inspection can take a long time, so we'll only be covering the highlights. But the most important thing to learn from the process is how to be an educated owner. So we're going to focus on some key areas that are common to most annual inspections. Let's start with the engine group. All of the engine systems are checked methodically. The IA begins by inspecting the overall engine and engine mount for cracks and signs of excessive heat and loose bolts. Then they check the engine cylinder compressions while the engine is still warm from the run-up. To do this, a tool called a differential pressure tester is used. The differential pressure tester measures leakage from the cylinder through the valves and past the cylinder rings at a point in the cycle when the cylinder should be sealed. Air pressure of 80 psi is fed into the cylinder, and the cylinder is checked to see what pressure it will maintain using a calibrated device. A result of 60 to 80 psi is generally considered to be acceptable without further investigation. Many owners view the results of the cylinder compression test as the most important factor in measuring the health of their engine. This really is not the case. In fact, the results of the compression test alone don't usually give us enough information to really determine how good or bad a cylinder is. In order to evaluate the engine and cylinders, all of the available information needs to be considered. Your mechanic will want to know how much oil the airplane is using, the results of the oil analysis, and a number of other facts before determining a course of action. If a cylinder is found to have a compression of less than 60 psi, your mechanic will need to investigate it further. Sometimes a low compression reading on a single cylinder is simply a function of the temperature or alignment of the piston rings. Your engine compression test is important, but there are a lot of factors that go into evaluating the health of your engine, and there may be many ways to solve the problem before removing the cylinder. Next, the engine's cooling airflow, and especially the baffle system, is checked. In order for the system to work, all of the baffles must be in good shape. Even a 1/4 inch gap in the baffle system can cause a noticeable increase in engine temperature. Both the rigid and flexible baffles need to be checked for leaks and proper positioning. Then the fuel system is examined. The fuel pump is checked and turned on momentarily to pressurize the fuel system. Then the lines are inspected for leaks and to make sure that all of the lines are secure and free from chafing. The carburetor bowl is drained to remove any sediment, and the fuel screens and filters are removed, checked, and cleaned. Next, the air intake system is checked, and the air filter is inspected and replaced if necessary. All air induction hoses are inspected for leaks and chafing. The carburetor is examined to make sure that all the cables are properly safetied and secure. Now that everything going into the engine has been checked, the inspection moves on to what's coming out. The muffler shroud is removed, and the entire exhaust system is inspected for leaks and overall condition. Exhaust leaks can be extremely dangerous in flight, so this is a very critical area. The oil system is checked, and the engine case and hoses are inspected. Most flexible hoses have a finite life, and it's very important to have them checked and replaced on a regular basis. If any of your plane's hoses are more than 5 years old, it's probably time to get them changed. The oil change is now completed by removing and inspecting the oil filter, installing a new filter, and filling the engine with fresh oil. You should always have your oil analyzed, and your mechanic will want to cut open your old filter to check it for metal. The vacuum system is examined next. The vacuum pump is checked to make sure it's secure, and the pump outlet is checked for excessive carbon dust. Excessive dust can mean that the pump is nearing the end of its service life, and this can be very important if you fly IFR. Finally, the electrical system must be carefully examined. Starting at the battery box, the battery is checked and all wires and components are inspected. The alternator and starter are visually inspected, and the alternator belt is examined for signs of cracking and to make sure that the tension is correct. Then the inspection moves to the ignition system. The ignition system inspection begins at the spark plugs. Each of the spark plugs are removed, inspected, cleaned, gapped, and reinstalled. And this isn't just something to be done during the annual inspection. Maintaining spark plugs is a legal preventative maintenance task, and you should clean and rotate them every 50 hours. Next, the ignition harness is examined for cracks and overall condition. An old harness can cause numerous ignition and radio noise problems, so it makes sense to replace the harness if it shows any significant signs of chafing or cracking. Following the harness, we come to the magneto. Most aircraft have two magnetos, one on either side of the engine, powering different plugs in each cylinder. This is what provides the ignition redundancy that helps make aircraft engines so reliable. Each magneto is examined for overall condition as well as age and hours in service. Magnetos are the most critical component in the engine's ignition system. This is because the engine uses the magnetos, rather than the battery, to generate the energy for the ignition spark. In the event of an electrical failure, the engine will continue to run normally due to this design. The exterior of each magneto and the quality of the wire attachments are inspected for defects. Magnetos have two types of wires attached to them: ignition switch wires, or P-leads, and ignition wires. The P-lead is a single shielded wire that comes directly from the ignition switch in the cockpit to each magneto. The purpose of the P-lead is to disable the magneto. The center conductor of the P-lead connects to the P-lead terminal on the magneto, while the shielding is grounded to the magneto housing. Inside the cockpit, when we switch between left, right, off, and both, we're controlling the P-lead and grounding out the magneto we want switched off. It's very important to make sure that the P-lead is intact and securely attached to the magneto. If the P-lead is loose or broken, the magneto is hot, and the engine could fire if the prop is moved. Because certain wire and switch faults may not be obvious, never assume that the magnetos are grounded. When servicing an engine, never move the prop unless the ignition harness is disconnected or the top spark plugs are removed from the cylinder to prevent the engine from inadvertently firing. As a safety precaution, always move the prop slowly in reverse of normal engine rotation. This will keep the impulse coupling from engaging, which could generate a sudden spark. Magnetos should be inspected externally every 100 hours and internally every 500 hours. When the engine reaches time for overhaul, or the condition of the magneto warrants a major repair, it can be just as cost-effective to replace the magneto instead of overhauling it. In the case of these slick magnetos, a complete kit, including new magnetos, a new harness, and even new plugs, is only marginally more expensive than overhauling your existing magnetos and replacing the harness. You'll also have a factory warranty covering the new parts. The last step of the ignition system inspection is to check and adjust the engine timing. To check the engine timing, the mechanic moves the prop to the point where the number 1 cylinder is in the top dead center position of the compression stroke. Then he or she will position the prop to the correct timing setting for the engine. The timing setting can be found on the engine's data plate. In this case, it's 25 degrees from top dead center. If we look at the flywheel, we can see a mark for the 25-degree point. This mark is lined up with the top seam in the crankcase, or we can use a mark on the front of the flywheel that lines up with a corresponding mark on the starter. The mechanic uses a magneto timing light, such as this one, to check the magneto timing. The lights indicate the opening of the points in each magneto. This is what causes the spark plugs to fire. If the timing isn't correct, the magnetos can be loosened and rotated to adjust the timing to the proper setting. Once the timing light indicates that both magnetos are set correctly, they can be secured in place. Between adjustments, the timing settings of the magnetos can shift due to magneto wear and vibration. Once the engine group inspection is complete, the cowl and spinner can be reassembled.